Okay, so we're looking for the absolute minimum and absolute maximum value for this function on this interval. So I'm going to take the left x and the right x and figure out the left endpoint and the right endpoint. So I'm going to figure out the y values. So when I plug -2 in, I get 2 to the 2/3. And 2 to the 2/3 can be written as the cube root of 2 squared, or the cube root of 4. Okay. Now I'm going to take 3 and plug it in. When I plug in 3, I get 9 plus 3, I get 12 to the 2/3, which can be written as the cube root of 12 squared, or 144. Now the problem is, for this part of the AP test, you're not allowed to use a calculator, so you're going to have to estimate what these numbers are so you can compare them to any other numbers. Okay? So you know that you know some of the perfect cubes. You know the cube root of 1 is 1, and the cube root of 8 is 2. So this number right here has got to be somewhere between 1 and 2, and it's got to be less than 2. And you know this number because you know that 5 cubed is 125, and 6 cubed is 216. So this number's got to be less than 6. So now you know that this number is definitely less than that number. Okay, and that's the end of step 1. So the end of step 1 is to figure out the left endpoint, which we did, and to figure out the right endpoint, which we did. And so far, this is all algebra and no calculus has been involved. And this is the end of step 1. 2 is to derive. So I found the derivative by using the power rule. I dropped down the 2/3. I subtracted 1 from 2/3, and then I chained. Once you find the derivative, you then want to set the derivative equal to 0 and solve this equation. But this equation, the way it's written right now, it's very confusing, it's very difficult to solve. We usually never want to work with a negative exponent, so I'm going to kind of rewrite this a little bit, and then it'll become easier to solve. So in the numerator, I have 2 times 2x plus 1. In the denominator, I have 3. And now I'm making the negative exponent positive by moving it down. Sometimes when you guys get a derivative, your derivative is going to be a fraction. And that makes the process a little more complicated. You want to take the numerator and set it equal to 0 and solve. So when I set this numerator equal to 0, I divide both sides by 2. I subtract 1, I divide by 2. And I get x equals -1/2. I repeat the same process in the denominator. So again, I divide both sides by 3, I raise both sides to the 3rd power, and I end up with a quadratic equation that I need to solve, which I can solve by factoring. And once I factor, it will give me 2 solutions. I want to make sure that both solutions, including this one, are all within the interval, which they all are. And what I have figured out, so the question now is, what is the significance, or why are these 3 x's so important? Well, first of all, they're called critical points, or critical numbers. And what critical numbers do is they tell you where any potential relative extrema might be. And a relative extrema might then turn into an absolute extreme. And so that's why it's important to figure out these particular x's called critical points. Okay. And that, once you figure out the critical points, that is the end of step 2. Okay, step 3 is to take your critical points that you get from the numerator and or denominator and put them into your xy table. And then you want to take your critical points and plug them into the original function, just like you did with your left and right endpoint. So when I take -1 and plug it in here, I get 0 to the 2/3, which is 0. When I take 0 and plug it in, I also get 0 to the 2/3, which is 0. So the only thing I've not figured out is -1/2. So let me take -1/2 and plug it in here. I get 1/4 minus 1/2, which is -1/4. -1/4 to the 2/3 is the cube root of 1/16, which is a very, very small number. It is definitely less than 1, but of course it is bigger than 0. And now you need to compare all the y values, all right? So now you're looking and focusing only on the y column. And you look for the lowest y value. So the lowest y value is 0, but it happens to occur twice. And now you've figured out your absolute minimum value, which is y equals 0. Your absolute minimum value is y equals 0. It just happened to occur at 2 different points. Your absolute maximum value is this number, which is 5 point something. It's a little bit less than 6. So that number right there is your absolute maximum value, or your highest y value. And now you've located your minimum value, which is 0, and your maximum value, which is the cube root of 144, and that is the end of the problem. Step 3. Okay, so we're done with the problem. We've answered the question, what's the lowest y value, and what's the highest y value, but I want to show you what you actually did here on this graphing calculator. So, this is the function you were working with, okay? And I've graphed it from -2 to 3. And what you first figured out in step 1 was where was the left endpoint. So it was right here, -2, 1 point something. And then you figured out the right endpoint, which was 3, 5 point something. 3, 5 point something. Okay, that was your first step. Your second step was to figure out all the critical points. So from the numerator, you got x equals -1/2. Okay? So if you look at -1/2, you'll notice that there's a relative max there. And the value of the derivative is 0, because that's a horizontal tangent line. Your other 2 critical points are x equals -1, which is here, 0, and x equals 0, which is here, 0, 0. And you'll notice that these are both relative mins, relative min, relative min. But the difference is that this derivative is not 0. This derivative is dne. And this derivative is also dne because we have corners here. And that's what's very interesting about this, about how it all works out, is that the solution you get from the numerator, x equals -1/2, because it came from the numerator, your extrema's derivative is 0. And you got these 2 answers from the denominator, and because it came from the denominator, the extrema, the values of the derivative there are dne. So numerator 0, denominator dne. What happened is you figured out the lowest point. The lowest point occurred here at -1, 0, and it also occurred here at 0, 0. So your relative extrema, your relative mins, turned into absolute mins. What you figured out next is that your highest point is here at the right endpoint. So your highest point, your absolute max, happened to be one of the endpoints. Your relative min, which is relative max, which is here, ended up not being the absolute max because it was lower than both the left endpoint and the right endpoint.